Hello, and welcome to today's lesson, Circles and Polygons, Unit 1, Lesson 2. So when we're in this lesson, we're going to be looking at identifying and defining right, acute, and obtuse triangles. We're also going to identify and define scalene, equilateral, and isosceles triangles. And then we are also going to identify and define a trapezoid, kite, parallelogram, rhombus, rectangle, and square. Okay, so looking at our quadrilateral shapes, our four-sided shapes. So now, when we classify triangles, we can classify them in two ways. The first way is classifying them based on their angle measures. So we have a right triangle that has one right angle, one 90-degree angle. And it can only have one 90-degree angle based on the rules of a triangle adding up to 180. An acute triangle. An acute triangle has three acute angles. And when we say acute angles, we're looking at the less than 90. So when I've talked about before, when you're trying to predict an angle before you solve, understand, is it 90? Is it less than 90? Is it greater than 90? Acute triangles have three angles, all less than 90. And then we have our obtuse triangle, where we have a triangle that has one obtuse or one greater than 90 angle. Now, we can also classify triangles based off of their side lengths. We have a scalene triangle, a triangle with no congruent side lengths. So we could put tick marks in to show that all three of those sides are different in length. We have equilateral triangle, a triangle that has three congruent sides, but also notice that it also has three congruent angles, because if all the side lengths are equal, all the angles have to be equal in an equilateral triangle. And then we've also already looked at the isosceles triangle, a triangle with at least two congruent sides. So technically, an equilateral triangle also fits the definition of an isosceles triangle. And remember, it's not just the side lengths that we know that are equal to each other. We also have those two angles across from those sides that are equal to each other. Now, quick test here. We've already went through the isosceles triangle. Can you name and label all the pieces? So do a quick pause, see if you can come up with the names, and then come back and see how you have done. Okay, when we're looking at our side lengths, our legs are the two lengths that are equal to each other, or congruent lengths. We've got the base, which is the third side. We have our base angles. Okay, the base angles are the two angles that are congruent to each other. And then we finally have our vertex, okay, which is the third angle that is not equal to, but takes up whatever is left over from 180 degrees. Okay, now let's look at some of our quadrilaterals that we have. Okay, a trapezoid. Okay, a trapezoid is defined by having one pair of parallel sides. Okay, in the trapezoid, we call these the bases. Okay, there's actually two bases to a trapezoid. It's the two parallel sides, but the other sides can cut wherever we would need them to cut to make a trapezoid. Okay, so we don't know about the lengths of the other sides, but what we know is it can cut anywhere, but we do have and have to have that parallel top and bottom. Okay, our kite. Our kite is defined, it's a four-sided shape, that has two distinct pairs of consecutive sides. Notice that they're not the same length. Okay, so we have consecutive sides on top that are the same measure or congruent, consecutive sides on the bottom that have the same measure and are congruent. And eventually we'll start to look at what happens with our angle pairs, because we have some angle pairs that are congruent and some angle pairs that are not congruent within a kite. And then we have our parallelogram. Okay, a parallelogram is a quadrilateral with two pairs of parallel sides. Okay, the nice part about a quadrilateral parallelogram is then we also know that we have pairs of congruent angles as well. But a parallelogram is defined by the pairs of parallel sides. The angles that come along with that are something that are nice and we add in overall. Okay, now finishing up our quadrilaterals, rhombus. Okay, we actually saw and talked about the rhombus a little bit ago. Okay, it's an equilateral parallelogram. Okay, so it is a parallelogram. It's a special parallelogram that has all of the four side lengths equal to each other. So we know that we have parallel sides. So if we say that it's a rhombus, we can also put in the tick marks to show that we're dealing with pairs of parallel sides. But even more importantly, we have the equal side lengths of the shape. Okay, finishing up our last two, our rectangle is an equal angular parallelogram. Okay, so it is a parallelogram. So once again, if we wanted, we could put in the tick marks to show us that we're dealing with pairs of parallel sides. But all of the angles are equal to each other in this parallelogram. And that's what makes the rectangular, or rectangle, not rectangular, the rectangle a special shape. And then finally, the square is a regular quadrilateral. It is a parallelogram. It is technically a rectangle. Okay, it is equal angular, but now it's even more. So the square fits the characteristics of a rhombus, a parallelogram, and a rectangle. And since it does all of those, it gets its own name. And we've got all of the possible tick marks. If we want to put the parallel line pieces in, we can too. Okay, just to show how special that shape is. And that concludes our lesson for today. Thank you and have a good day.